Assalamu alaikum warahmatullahi wabarakatuh. Hi friends, in this video I will be explaining you the types of experimental designs that we are using in research and how to construct ANOVA table using SAS software. Right, so typically we use three types of experimental designs in research. The first one is complete randomized design, which we acronym as CRD, complete randomized design, and the second one is RCBD, which we acronym as, which is the acronym format of randomized complete block design, and the third one is LSD, which stands for Latin Scale Design. Latin Scale Design. Okay, now we have to know why we use this method for research, right? So let's say we have 20 experimental units, right? So we have to first know what experimental units are. Experimental units and treatment. Okay, now treatments are the categories of independent variable. For example, let's say we have to know if there is any relationship between the weight and diet groups, right? So here weight and diet groups, weight, diet groups. Okay, now let's say we have two types of diet groups, diet 1 and diet 2, right? So after this experiment we measure the weights of these 20 people. Let's say for this research or for this experiment we have taken 20 people, and we assign these 20 people for these two types of diet groups, and later at the end of the experiment we measure their weight. Okay, so now these 20 people are called experimental units, and we have treatments. The treatments are diet 1 and diet 2, right? So categories of these independent variable, right? So here let's say this is x1 and let's say this is x2, and the weights are called y, right? So let's say y follows to x1 plus x2. So this is the rough statistical model, right? Now let's say we have 20 people, and we have to assign these 20 people for each type of diet randomly, right? So as the name suggests, completely at random we have to assign these 20 people. So this treatment 1, which means diet 1 will receive 10 people, and this diet 2 will receive 10 people. Okay, now this is all about complete randomized design, and I will explain you how to construct ANOVA table for CRD using SAS software, which stands for Statistical Analysis Software or Statistical Analysis System. Okay, now we will move to the second experimental design, which is complete randomized design. I'm sorry, RCBD. Randomized complete block design, RCBD. Now I will take the same example. Let's say we have 20 people, but we have variation gender wise also, right? So let's say we have 10 male and 10 female, right? So in the earlier case, if we have all 20 male, then we can use complete randomized design because there is no variation gender wise. But if we have any variation gender wise, then it's not nice to go for complete the CRD method. Then we have to go for RCBD method. Okay, now what we have to do is we have to categorize these 20 people based on their sex. The first one is male and the second one is female, right? So this classification is called block, right? And this is block 1. Now let's say this is block 1, and this is block 2, right? So for each block we have to assign the experimental units using CRD now. So now each block will receive experimental units based on CRD method, right? So now we will apply CRD here. Now here we will apply CRD. Okay, so the summary is we have 20 people, so 10 male, 10 female, so there is a variation gender wise, so we will call it as block. So block 1 has 10 male and block 2 has 10 female, so we have to assign these two people diet 1, diet 2, right? So from block 1 we will assign 5 male and for diet 1 and 5 male for diet 2, and from the block 2 we will assign 5 female for diet 1 and 5 female for diet 2, right? Okay, so this is the rough idea for CRD and RCBD. Before going to LSD method, we will just try one question. Okay, so now this is the data layout that has been given for us to perform CRD method on SAS software. So fresh weight of plants under different doses of fertilizer, right? So here weight, right? So as I told you, weight is the dependent variable, which is y, yield, right? And plants under different doses of fertilizer. So we have 3 types of fertilizers and those are called treatments, right? So we have treatments. So we have 3 treatments: treatment 1A, treatment 2B, and treatment 3C. Okay, and here you see now 1 2 3 4 5 1 2 3 4 5 6. So we have 30 plants, right? So the number of plants we have is 30, right? So these plants are now experimental units, right? So since we have taken the same type of plant, we are going to go for CRD. So if we have any variation among the plants, then we will go for RCBD. But since we have taken the same type of plant, right? So for example, if it is coconut, then all 30 are coconut, right? So now for treatment A, we have to assign 10 plants, and for treatment B we have to assign 10 plants, and for treatment C also we have to assign 10 plants. Okay, right. Now we have to summarize this data layout for our easiness like this, right? So here fresh weight of plants under different doses of fertilizer, right? So we take a plant and we administer the fertilizer, and after some period of time or after some weeks or months, we just measure the weight of the plants, right? And we have denoted the data in this layout, and since we have 10 replicates, right? So since we have 10 replicates, these are called replicates. So replicate is not a main effect. So for treatment A we have 10 plants, for treatment B we have 10 plants, for treatment C also we have 10 plants. Now we will just see how we have to construct ANOVA table using SAS software, and how to perform hypothesis testing. Let me just go to this one. Okay, so this is the SAS software, and here we have 5 windows. Anyhow, we will be using this program editor window and output window, and in this log window we will be given the summary of what we have, what programming we have written, and if we have committed any errors, this will be indicated in this window, right? For now we don't need this. Okay, so I will just type the program here. So I will just name it as data CRD, and at the end of each line I have to use semicolon, and after that I have to put input, right? So here we have treatment and yield, right? So here we have treatment and yield. These are the column variables. So for each treatment we have yield, right? So I have just summarize the data and typed here. So I will just copy this and paste on that. Right. Now data CRD input, we have treatment, we have three types of treatment here. We have three types of treatment here, and for each treatment I have typed the corresponding weight of the plant, right? So after that again I have to press enter and type semicolon, then procedure proc ANOVA, then again semicolon, class. So under class I have to mention the main effect. Here the main effect is treatment, and then model y is equal to treatment, then run. Okay, then I have to press the submit button, right? Oh, I think I have made a mistake. I have closed the output window also, otherwise I would have seen the error. Why? Oh, okay. This is output window, program editor. Right, so data CRD. Okay, so the mistake I did is, I think I didn't mention this dollar symbol, right? So since we have mentioned the treatment in a string variable, we have to use dollar symbol. If I named the treatments in numbers, I don't want to type this dollar symbol. So that was the mistake I did there. Now I will just submit it. Okay, so this is the ANOVA, right? So here you can see the treatments, right? If they want to ask okay, so in the question, if they ask to write down the or construct the ANOVA table, now you have to write down this. Now I will just tell you how you can write the hypothesis and do the rest. Let me just check if I can insert the screen clipping. Okay, so based on this output, what I can tell is, now I can write down the hypothesis, right? So H naught, I will tell both diet groups are same, right? Otherwise I can tell all diet groups are same. Since we have only two diet groups here, you can mention both diet groups are same also, right? And H1 is at least one diet group is different from other, right? Now we will just check now we can consider this F value and P value also to decide whether to reject or accept null hypothesis. Anyhow, if we use F value, then we have to go for the F table value also, but typically we consider 5% significant level, so alpha value is 0.05. then we can just compare the P value, which is P is equal to 0.05. 4719, which is greater than alpha value, right? So we cannot reject h naught, we cannot reject h naught. So at 5 percentage significant level, we can statistically conclude that, right? So if we cannot reject h naught, we have to accept it, right? So both diet groups are same here, right? So if we reject h naught, then we will say at least one diet group is different from other. In such scenario, we have to identify which group is, if we have more than 3, we have to compare which pair will be different, right? So here this is only CRD, we don't want to go for that one. Now we will go for the next model, which is RCBD. Okay, so now RCBD again, let's say fresh weight plants under different doses, but here we use 3 types of plants, right? So let's say here we use 3 types of plants. Let's say we use 3 types of plants, right? So plants, but we have 3 types of plant, but it is not mentioned here. So in such scenario, we have 3 blocks, right? As I explained you earlier, we have 3 blocks. But we use 1, 2, 3, 4, 5, 6, 7, 8 treatments, right? So here we have 8 treatments, and we have 3 blocks, and for each block and for the corresponding treatments we have yields, right? So yields are given in numbers, right? Now we have to find the treatment total and grain total and all for constructing a ANOVA table manually. Anyhow, since we are going to use the software, I will directly feed the data into the program editor window, right? So here data RCBD input, we have treatment, then we have block, and then yield, right? Then cards. Now you see here I have just okay, so now I will just copy this and paste on the program editor window, and open this also. Okay. Now, how I have entered the data is, uh, okay. Now you can see all the windows here. I have shared the OneNote window and the program editor window of SAS software. So I have named A, right? So treatment, I have A. So but for treatment A, I take experimental units from all three blocks, right? So A treatment, now if I consider this 30.85, it comes under treatment A but block 1, right? But 38.01, this one treatment A but coming from block 2, right? So likewise I have entered all the data. Now I have to construct ANOVA table. So proc ANOVA class. Here under class I have to mention the mean effect. Now treatment is a main effect and block is also a main effect, right? Then model is equal to yield. Yield is equal to treatment block. Then run. Okay. Oh, again I have made a mistake. I think I forgot to enter dollar symbol. Okay. I think again I forgot to enter this dollar symbol for treatment. You have to be very careful. Okay, so treatment dollar, because if you enter the treatments in numbers, then you don't need to put this dollar symbol. But if you use alphabet letters, then you have to mention that you have entered string values. Then you must enter this dollar symbol, right? The rest is okay. Now I will run it. Okay, so this is the ANOVA table for this, right? So let me just open this and insert. Okay, I will go to this page and enter. I will just insert this output. Okay. Right. Now what I have to write is, I have 8 treatments, right? So unlike the first question, here I have 8 treatments, right? So I have to check if there is any significant differences among these 8 treatments, and if I conclude that at least one pair of treatment is different from others, then I have to identify which treatment pairs are significantly different. For that for that purpose I will use mean separation methods, right? So popularly we use LSD method. LSD stands for least significant difference method, right? Okay. Now I have to first write down the hypothesis, null hypothesis. All treatments are same. H1 at least one pair of treatment is different from others. Okay. Now I have to check the p-value of this treatment, right? So this is 0 p value is equal to 0.0021, which is less than alpha value, which is equal to 0.05. So we reject h naught, and at 5 percentage significant level, we statistically conclude that at least one pair of treatment is different from others. Now, if we reject null hypothesis and conclude that at least one pair of treatment is different, now we have to identify which pairs of treatments are significantly different. For that, we have to again go for this SAS software, right? Again, program editor, Control V, and make sure that you copy the data before you submit it, so that if you commit any mistakes, then otherwise you will have to retype the data, right? Okay. Control C, Control C, Control V. Now again, for the for identifying which treatments are significantly different, I had to use mean separation method. Now we have done a test and all, but popularly we will use LSD method, right? So means, right? So this is the code, means treatment. We have to identify the now we have to identify which treatments are different, right? So we will use the code mean treatment, and the method that we are going to use is LSD. Now we will run this. Okay, now you see this is the output, and what you have to write is, you can just see this least significant difference is 5.572, and the mean of each treatment is given here, right? For treatment A, the mean is 34.653. For treatment C, the mean is given. For 8 treatments, we have been given the means, right? So now we have to compare the each treatment, right? And check if the difference is higher than the LSD value, right? If so, then we will conclude that the considered pair will be significantly different, right? So now you see, again I will insert this output. Okay, so here if you consider A, right? So XA minus XC, and we will take the modulus to get the positive values, even if we subtract the lowest from the highest, highest from the lowest. Okay, so here A minus C means that is 34.653 minus 32 minus 510, so this will be equal to 412 point, right? So this is less than LSD, right? So mod of XA minus XC less than LSD. So least significant, difference mean this is the lowest difference, significant difference, right? So if the difference among the treatment that we consider is higher than LSD, then we will say that considered pairs will be the considered pair will be significantly different. So in such scenario, if I consider this E and A, right, so mod of x A minus mod of x A bar, right, bar mean, which will be equal to 34.653 minus 22.117. So like 6 3 5 34 12, I think 12.536. So treatment A and E are significantly different. Likewise, you have to compare all, right? Okay. Now we will go for the third experimental design, which is LSD. So as the name suggests, now as the name suggests, here Latin square design, right? So here we will have treatments row and column, right? So here number of treatments should be equal to number of rows, should be equal to number of columns, and the treatments, there shouldn't be any replicates in treatments column wise and row wise, which means one treatment should occur only in one row and one column, right? So if you consider this row A, there is no A here, A, C, D, B, A, D, B, C. Now let's say if you have C here, instead of this B, here you have C and here you have B. So this will be again come as RCBD, not LSD, right? Okay. Now a farmer wishes to test the effect of 4 different fertilizers A, B, C, D, right? So here we have 4 treatments and the number of rows 1, 2, 3, 4 and number of column 1, 2, 3, 4. So the condition holds, then we can use Latin square design. Variability of this, he uses fertilizer. Okay. Now after identifying which design we have to use, now we will open SAS software and we will go to the program editor window and data LSD. Okay, I have just, I can use this. Okay, so data LSD, I will just okay, so now you just see this. Okay, data LSD, right? Input treatment, and don't forget to put dollar symbol if you are naming the treatments in string values, and row column, right? So here horizontal row and vertical column, right? Okay, now row column, right? So and yield, right? So yields are these numbers, and these alphabet letters are treatments, right? So now we have to just feed the data to the program editor. How you can do this is you can observe each cell, and this occurs, this A, the treatment A occurs in first row, first column, and the yield is 18. So treatment A, first row, first column, and the yield. Now we will go row wise, right? So now C, treatment C occurs in first row, second column, and the yield is 21. Likewise, you have to enter all data, and finally you have to, you shouldn't forget this semicolon, and procedure is ANOVA. Then class, the main effects are treatment, row and column. Model is equal to model, y is equal to treatment, row, column, and then run. Now we will just run this program and obtain the output for the further analysis. Let me again, so this is the output that this SAS software has generated, and now I will insert this also for you. Okay, so now we have to write the hypothesis. H naught. What is the H naught? How can you write the H naught? Farmer wishes different fertilizers, right? So all fertilizers have the same effect, is the null hypothesis, and at least one pair of fertilizers has the different effect or different means. So that is the hypothesis. All fertilizer gives same yield H1, at least one pair of treatment or fertilizer has different mean yield. Likewise, you can write the hypothesis. Then for treatment, this is the p-value. P-value is less than alpha value. Then you can conclude that at 5% significant level, the treatments, the at least one pair of fertilizer gives the different mean yield. Then you have to identify which pairs of fertilizers give the different output or different mean yield. For that, again you have to go to this SAS software, and again you have to just Control C, then Control V. So now again means, right? So treatment, and the method is LSD. Just run this, and again it has generated the LSD for the treatments. Now I will. Okay, again you have to consider, or you have to compare these treatments. Now for each treatment it has given the mean, right? So now this is the least significance difference. Now if you compare the means pairwisely and see the difference, if the difference of the considered pairs is greater than the LSD value, then we can conclude that the considered treatments will be significantly different, right? So now 23, 21. Okay, so you can just see XD minus t bar like that. And okay, now you can just subtract the values and compare. If you get a value more than this LSD value, then you can compare accordingly, right? So hope you got benefits from this video, and we will meet in the next video. Thank you.